Elementary Science Class 6. Light, Shadows, and Reflections. Have you ever wondered how we see objects around us?
Yes, I have. How do we see them?
We see objects because of light. Without light, we wouldn't be able to see anything.
Oh, I see. What about at night when it's dark? Can we still see objects?
No, we can't see objects in the dark. We need light to see them. If you go into a completely dark room, you won't be able to see anything.
That makes sense. What about objects that give off their own light like the sun?
Objects like the sun that give off their own light are called luminous objects. They help us see objects during the day.
What about objects that don't give off their own light like a chair or a painting? How do we see those?
We see those objects when light from a luminous object, like the sun, a torch, or an electric light, falls on them and then travels towards our eye. This is how we see shadows and reflections too. Transparent, opaque, and translucent objects. Opaque objects are those that we cannot see through at all. Transparent objects are those that allow light to pass through them, and we can see through them clearly. And translucent objects are those through which we can see, but not very clearly.
That's interesting. Do you have any examples?
Sure, an eraser, plastic scale, pen, pencil, notebook, single sheet of paper, tracing paper, or a piece of cloth, are all examples of objects we can test for transparency, opacity, and translucency.
How do we test them?
We can look at something far away through each of these objects and see if light from the faraway object can travel to our eyes through any of the objects. This activity will help us understand the differences between transparent, opaque, and translucent objects.
That's a great way to illustrate the importance of the topic. It's fascinating how a given object or material could be transparent, translucent, or opaque, depending on whether it allows light to pass through it completely, partially, or not at all.
What exactly are shadows? Maisie, have you ever wondered about shadows?
Yes, I have. Shadows are formed when an opaque object blocks the light source.
That's correct. Did you know that shadows can give us information about the shapes of objects?
Yes, and shadows can also mislead us about the shape of the object.
Did you know that we need a source of light and an opaque object to see a shadow?
Yes, that's true. Without a source of light, we cannot see a shadow.
Shadows can only be seen on a screen like the ground, walls of a room, or other surfaces.
Yes, that's right. Shadows can only be seen on a screen.
Did you know that shadows can change shape?
Yes, I did. When the light source changes, the shadows change.
A pinhole camera. Have you heard about pinhole cameras and how they work?
Yes, I have. They are pretty fascinating.
Did you know that you can make a simple pinhole camera with just 2 cardboard boxes?
Really? That's amazing. How does it work?
Well, you make a small hole in one box and cover it with tracing paper. Then, you slide another box inside the first one, and the image is projected onto the tracing paper.
That's so cool. What can you use a pinhole camera for?
You can use it to view distant objects, take pictures of the sun during an eclipse, and even create upside-down images of people and objects.
Wow, I had no idea. Are there any other practical uses for pinhole cameras?
Pinhole cameras are also used in scientific research, such as studying the behavior of light and the formation of shadows.
That's really interesting. I never realized how much science is involved in the simple concept of a pinhole camera.
Yes, it's amazing how something so simple can teach us so much about the world around us.
Definitely. I'm excited to try making my own pinhole camera and see what I can learn from it.
Mirrors and reflections. Have you ever wondered how mirrors work?
Yes, I have. I know that mirrors reflect light, but I'm not sure how they do it.
That's right. When light hits a mirror, it bounces back and reflects an image of whatever is in front of it.
I see. So, we see our own reflection in the mirror because the light bounces back to our eyes.
Exactly. And mirrors are not just used at home. We also see reflections of other objects in the water of a pond or a lake.
That's interesting. Can you give me an example of an activity that demonstrates how mirrors work?
Sure. Here's an activity. Hold a mirror in your hand and stand at one corner of the room. I'll stand at another corner with a torch in my hand. I'll direct the beam of the torch light onto the mirror that you're holding. Do you see a patch of light on the other side?
Yes, I see it. What does this activity show?
This activity suggests that a mirror changes the direction of light that falls on it. And here's another activity. Fix a comb on one side of a large thermocol sheet and fix a mirror on the other side. Spread a dark-colored sheet of paper between the mirror and the comb. Keep this in sunlight or send a beam of light from a torch through the comb. Do you see a pattern on the sheet of paper?
Yes, I see it. It's a pattern of straight lines. What does this activity show?
This activity gives us an idea of the manner in which light travels and gets reflected from a mirror.